Hey all there, you Visuiners. Welcome back. Good to see you again. In today's episode, we got us a visitor. His name is Q-Card Dude. So, say hi, Q-Card Dude. You know, I try to make programming fun and enjoyable because sometimes it really sucks trying to figure it out. So, let's get to it. Try to have some fun, and good job, Q-Card Dude. Right on, let's get it done. So I do have a Patreon account that helps buy sometimes hardware and stuff. Like if I burn a speaker out, you never know, something happens, you know, sometimes. That should do it. And oh shit, I got smoke. Fuck. And, you know, all the files are available for this project. You do not need to donate to get the files. Just leave a like, a comment, a share, you know, something like that. And, you know, be cool about it. Besides, you know, little teeny tiny speakers that you rip out of old stuff and they get burned up are sometimes hard to come by, you know. Now, speaking of Patreon, one of my subscribers, Taylor Ladikos, sorry, has a robotics question. Now, his question is, he says, I'll try to describe the project as concise as possible with some basic objectives. His first objective is record and play back servo animations. He wants to be able to move a servo, push a button, save it, turn it somewhere else, push a button, save it, save the steps. So when you turn it back on, you can recall those steps. Moves an arm, grabs something, and moves it back. That's the main objective. The second one, remember and store the servo starting positions. When you turn it on, you don't want the arm to be banging into the table or whacking you in the face or, you know, spinning around and stripping the freaking gears in the servo because they go so good. You don't want that to happen. Trust me.
There's kind of a two-step. If you look really close, it's kind of jumping back and forth in the center ones there a little bit. That's, I don't know what is doing that there. That's throwing that damn thing everywhere. But it's just that one. It's kind of weird. I don't know. I'll figure it out.
So you want to be able to turn it on and it goes to a default start position. The third one is a screen with a menu to select saved animations and positions. So you can make different slots. So you can say, okay, let's do this. Go over, pick something up, drop it off. Okay, now do this. Go over here, pick it up, drop it off. Okay, let's do this third thing. Go over here, pick something up, drop it off. Different animations, different steps on an arm. Okay, I'm going to do it with 10 locations in an EEPROM module. And I'm not going to do it with robotic arm. I'm going to do it with audio because, yeah, I'm lazy like that, you know. Sorry. You know, there's different kind of hardware you can use for this. I'm using the ESP32 dev kit version 1. Reason being, they're fast, they got good memory, they got Wi-Fi, Bluetooth, and they're cheap. So that's what I'm going to use. You can use Uno or whatever for this. So that's the board that I'm going to use. So my cue card says stuff that you need. An Arduino, we already went over that. A few other things. You're going to need 3 resistors, 3 push buttons. The resistors are to pull it down. You're going to need a potentiometer, and yeah, a USB connection. And that is the bare bone basics that you're going to need to be able to do this project with. You don't need all the stuff. Not all of this. You don't need it all. Right, so now, stuff that you should use. First on the list is an EEPROM module. I'll explain that one in a second. One of the requirements or the suggestions for this project was an LCD screen so you can read the information out. So we're going to be using the 16:2 to read all the information out. And we're going to use, instead of a servo, we're going to make sounds with it. We're just going to use the L298N. the basic H-bridge for motors, you can make sound with it too. So hey, it's a good cheap amplifier. I use them all the time, and you saw it fried that friggin' little tiny speaker. So yeah, watch that. Alright, so the reason I use the DS3231 is it's got the really reliable clock on it. It's I2C interface, really simple, works really well. It's got a battery backup on it, and it's got a 4 kilobyte memory chip on it, which is really fast, which has a 32 byte page write option right there. I'll include the PDF with the download, but it's really fast, and it also at least 1 million write cycles per data bit. So on the Arduino, you might get 100,000, you know, if you're lucky. So if you want to save the EEPROM in your Arduino, experiment with everything on the DS3231 because they're cheap and they got a bunch of memory that you can use, and they do work very well. All right, that's why I use them. I save the EEPROM in the Arduino itself. All right, so this is the sketch, and I know your brain right now is doing exactly what my robot did in the past. Cutesy one. Oh, I got a fire going on here with him. Let me turn him off. That sucks. You blew it. So the one thing to remember on this is that there's 3 main sections, alright? There's your input down right underneath me is where the input comes from the buttons in the potentiometer. There's a bunch of ifs. There's a bunch of detect edges in there for when you push the button and you release the button. There's a couple ands. There's a nor. There's a bunch of different switches inside there to get the pulses for like you're riding the horse, you know. So that's where all that happens, is right in the section below. Up in the top, up top, that is where the memory for the EEPROM is. You don't have to use the RTC module. You can put the EEPROM values in the Arduino if you need to. Okay, that's one thing you can change. Just put them over into the Arduino, make them in that, you know. So up in the top where all the switching is and where all the demuxs, there's 3 demuxs up there, components. And yeah, that's what handles that. Now down in the bottom corner is where it handles startup to flush and refresh all of the arrays. And it's also where it has the display sequence. So it refreshes it, and then it clears the screen, and then it shows it on the LCD, or then it prints it in the serial monitor, and then it waits for a second, and then it plays the sound, you know. And it's got a step by step thing that has to happen for all this to work right. And I know you're feeling just like my robot, Cutesy one.
This is wow, what was that?
That was seriously the funniest thing that has ever happened to me while I was building a robot. When I blew his friggin' face off, found it like 2 weeks later on this other side of the room. You see? This is the time my cue card says it's begging time. I don't beg, I tell. You see? So why don't you head on over to my YouTube channel, you see, and hit that subscribe and like and share and comment, why don't you? See? And then maybe you can like go to the Patreon and get all the files for free. No charge. Just leave a like. You see? You'll see. Thank you. Alright, so now my next cue card says that I gotta walk you through the startup, what the different slot locations do, how to edit and play it, what the up, down, and select button do, and what the twisty turny knob does if you're playing or editing the tones. So yeah, I guess that's what we're gonna do. Okay, to get this started, all you gotta do is turn this thing on, and it's gonna flush the memory, and it's gonna set itself to slot 0. Alright, Now that's the play spot, and it gives you no reading on the knob or anything saved in EEPROM. So if you twist the knob, it'll just play the tune that you give it. That's just on start right there. That's the first option. So after you've had your little bit of fun playing around with the knob, since you're on slot number 0 right there, you can just hold down the select button and it will play the stored values that are in EEPROM. It'll just go through them one by one and keep cycling. While you're playing, you can change the second tone. Get it? Get it? Alright, now your up-down button operation, when you first turn it on and start it, you're on play and slot 0, no reading on the knob. You know, you can do whatever, you can play a little bit. But then if you push up, it goes to slot 1, and then it says edit up here. Now that means you can change the value. This is the value that's stored. 126 is the frequency. This is what's going in. You can change the value and then press select, and it will store that new value in EEPROM, and then you go to, let's say, slot 2. And it's at 132, but you wanted a higher pitch. So let's bring it up, and then we'll press select, and it changed it to 456. Go to the next one, and it's at 49. That's a really low frequency. Let's bring it up. Alright, and then we'll store that one and go up, and let's bring it up a little bit more and save that. Alright, now we're at slot 4. We don't want to do all 10. Let's go back to 0, hold the button down, and it changed. If you notice, it changed all the stored locations. It's reading the new values that you put in with the knob thingy. Yeah. One thing that is, I think, a bug, if you take it to, like, say, number 1, and then you want to change the value, let's drop it down, okay? If you press select and hold it, it won't change the value when you turn the knob. It locks it out. It leaves it at that number, alright? So now if you go back to 1, you get the new 165. So let's do that again. Alright. 0, 1. It's at 409 right now. Let's hold the button down. Turn it down. We're putting in 63. Let's let it up. And let's go back down to 0. Let's see what it says. 409. You see, it did not save it because I was moving the knob while doing this. You see what I mean? It's weird like that. But you can also hold this down and change the tone. So yeah, have fun. Alright, so we're gonna get back at this stuff, but don't go beating yourself in the head. Alright, so anyway, the next cue card says that we're going to go over the memory array, alright, and how it works. So basically, I told you I was going to do this short, sweet, to the point, and get as much info in as quick as I can. It uses 3 DMUX components on the left side there. 1, 2, and 3, okay? The top one is the read or recall. The next one down is the remember or write. And the last DMUX on the bottom is the data DMUX, okay? It tells it which EEPROM location it's going to go to. So these all work on the counter. The counter tells it which area to select, what one we're using, 1 through 10. There is none for 0. 0 is just connected straight through. There's no EEPROM location for that. So that when you push that button and you're on 1 through 0, 1 through 10, instead of sending the signal to read it and display it, it's going to write it. That's where that switch comes in, right there. Okay? Alright, so here we are. That wasn't so bad now, was it? The next step is the output in the data timings. Now, when I say data timings, what I'm mainly referring to is the amount of time that it's going to take for the clock signal to get to the remember or recall on the EEPROM, and the EEPROM send that information. Once it gets that information, it has to decode that information and then make it usable so that it can be displayed and output through the speaker. Okay, now that's what I mean by the data timings. And there is a certain sequence that you have to follow when you do this, because if you just hook everything up without clocks, you're going to get false information, you're going to get errors, because some data will get somewhere before the other stuff that you need, right? And you know, before long you get, you know, something going wrong and breaking. You know, it happens. Okay, so when it starts, it's going to refresh all of the EEPROM data. It's going to reset the counter, it's going to reset the pulse for the audio. It's going to refresh the name array for edit and play. It's going to trigger the display sequence. Now, the start routine is separate from when it's normally running and it detects a button press or button release or a timing change on the Kanabi thingy, you know. But anyway, so that is the start sequence only. Okay, so now after it does the start sequence, it's going to go into the display sequence. So the first thing it's going to do is it's going to refresh the array name, the name for the menu, like edit or play or whatever you want to name it. There's 10 spots in there, or 11 spots. And it's also going to clear the LCD in that same 10 millisecond stroke. After that, it is going to build the menu names and the menu item, the two lines on the display, top one and the second one. It's going to build those together with the information that it received from the EEPROM. Okay, after it builds those two, it is going to go ahead and clock the serial output. Right after it does that, it is going to display the data to the LCD screen. Okay, and then after that, it is going to send the signal to start the on-off timer, the digital timer that enables the pulse generator. And the pulse generator is what turns the H bridge on and off and makes the sound, the tone, through the speaker. So that's basically the whole display and output sequence right there. Not really that hard. You just have to make sure that you give the system a little bit of time. I might be, you know, might not need 10 milliseconds, maybe 3, 2, who knows. Depends what you got, but go ahead and play with it. The Vulcan Logical Brainiac game. Yes. Hope you're ready for this one. Inputs and the logic crap. There's a lot of it. And on the ESP32, you got to be really careful. There's some certain pins you can't use for pull-ups or inputs and stuff like that. So I use the safe pins, number 32, 33, 34, and 35. Those are what are connecting my 3 buttons and the potentiometer. Those are the 3 inputs that I'm using for that. Now on pin 32, when it comes in on the potentiometer, right here, I'm going to start right there. That's the first sheet, is just this part. Okay, so here we go. Let's do this. You'll know sometimes when you're playing with the knob, the number's jumping around and it's not a stable number. This is a technique to get that stable. When it comes in from the potentiometer, it gets averaged out. I'm using a long period, like 75 milliseconds or something like that. It's a really long sample time. All right, and then that range is mapped to the values that I'm using. I think it's 31 hertz to 988 hertz. You know, the first octave through the 5th octave or 4th, something like that. And then after that, there is an only changed component there, and it's set to 2. This is so that it's not beep 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 beep, it's continually not jumping back and forth and triggering the snapshot to go off, and it'll keep beep 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 beep. You see what I mean? It's a filtering process. It's gonna level out all of the inputs from the potentiometer. Okay, it is really super important. I recommend this kind of setup for any kind of analog input to level it out. Don't just run it straight from the input pin. That's a bad idea. All right, bad. After the filtering process, let's call it, is done, it's going to go 2 places. First is to the snapshot. All right, and it's going to get ready to see if the compare, and it also goes with the compare value. If it is not equal to the same number that is currently stored in the snapshot, all right, it's gonna say nope, it's not equal. All right, and that is going to trigger the 2 detect edges. Now this detect edge, one is rising and one is lowering. When it says nope, hey, we gotta fix something here, and it's going to clock out on the rising detect edge, it's going to trigger the snapshot number once to get the new number and save that to see if you keep moving it or not. If you don't take the snapshot, it's not going to know if you're still moving it. All right, right up here, this remember integer. Now when it says that detect edge says okay, it's falling, everything's kosher, I'm going to tell this dude up here that's supposed to remember this number to friggin' remember it. And that's the whole process of filtering it, checking to see if it's the same number. If it's not, making it the same number until it's even, and then saving that number. That's the whole input process for the potentiometer. So, yeah. Alright, now getting into the buttons and the logic in the switching, okay? First thing, on the ESP32, for buttons, for pins 33, 34, and 35, you have to go into the properties for the board in Visuino. You have to uncheck the auto configure box in the properties for those 3 pins, and then select the pull down. Enable pull down is pull down on all 3 of those pins. If you don't, it's going to try to use the touch sensor, and the touch sensor is way more sensitive than a standard push button. All right, and it will interfere with it. It took me a while to figure that one out. I was getting a lot of false signals, so make sure you do that one. That's a good one to remember too, honestly. Okay, back at the list here. Now the up button has a digital input pin, digital toggle switch. Now this is for if you're on spot 0 or spot 1. It uses the compare value, and it enables or disables for when you hold it down. It either plays or it edit. That is what that digital toggle switch is for on the up button. Both the up and the down button have a detect edge connected right straight to it. Now this is for the counter. This does the counter thing. Another section controls with a detect edge rising and falling, with the release and the pushing and the actual switching when you push it and release it. Okay, remember that the first 2 detect edge is just for the counter. All right, what I did was I used a digital OR with 3 pins component to detect when any button is pressed to trigger the display and output sequence. So whatever button you push, it's going to send that trigger to the display sequence, and when you let it off, it's going to let it run. That's what the OR does. That's this right here. These 3. That's it. So we have finally reached the last part. What does the enter button do, and what are those 3 detect edges with the SR, the set and reset flip-flop, and that pulse generator? Well, the pulse generator right down here underneath me is set to 3.25 per second. That's how many times it's going to advance through the notes. You can change that to slower or faster, like you're running on a horse, or you're galloping. You see what I mean? All right, the SR flip-flop. Now, if you push the select button, the last one, and it's on the compare value right here is equal to slot 0. All right, it is going to allow that button push, and when you hold it, to activate the SR flip-flop, which engages the pulse generator. All right, when you let it off is when it resets the SR flip-flop, turning off the pulse generator. Now also, when you let it off and it resets back through the system and deactivates the count, it's going to send a pulse for the detect edge falling to redo the display and the audio. And that's it. That is what that flip-flop is down there for. It just advances the note count. That is all it does, right? And that is the end of the flashcards. Yay! Don't forget, make sure you subscribe, like, comment, or share the YouTube video. And also, you can get all of the files for this build and any of the PDF files and the pictures for the pinouts and things like that. Everything is available free on my Patreon, patreon.com, aka Pigeon Kicker. And yeah, just leave me a like or a comment or something there, you know, maybe $1 a month. It'll help me get more paper. Take it easy. Peace, and thank you for watching again.